Wonderful. Okay, thank you so much for having me. So this one is extending Spark Machine Learning, and this is probably most useful to the people that are really big nerds. And if you're not, sorry. Anyways, I'm Holden. My preferred pronouns are she or her. I work at IBM. Lots of other people have told you about the wonders of IBM already, so I'm going to skip that today, but it's awesome. And you should definitely come work for us or buy whatever it is we're selling. You want several mainframes. So this is a somewhat hokey, but cats love it, machine learning pipeline system. And this is sort of Spark's interpretation or reinterpretation of the sci-kit learn pipelines. And we can see that we can sort of chain together these different stages that we have. And there is this tokenizer, and we have this hashing TF, and then we have a string indexer, and we have naive Bayes. And the last two are colored a different color because they need to see some data before we can start to sort of use them directly, right? Because we can tokenize our data without having to do any training, or at least if I'm using, the high quality space tokenization of English, it's going to work 100% of the time. But for a string indexer and for naive Bayes, I actually have to train on some data, right? And then once I fit my pipeline, I get back this transformer that I can apply on my new records, and I can predict things, and I can do awesome stuff. The only downside is this pipeline model is really wonderful, and there's all these really cool meta algorithms on top of it, like I can do cross-validation for parameter searching, I can do all sorts of wonderful things, but my models have to be part of the Spark pipeline ecosystem. So I'm going to look at how to sort of go beyond that. How can we make our own pipeline stage? If you're a giant nerd or you work with some giant nerds and they're like, you know what, Spark just does not have this algorithm, I can't use it, you can be like, you know what, we could trick our boss into thinking it's a good idea for us to spend a month implementing it on our own. And so after you've done that part, and you can have your boss email me, I'll say it's a great plan. You can go ahead and start implementing your stuff. Now, if you're implementing something pretty simple, you can just implement an estimator. So if you're like, Holden, I don't actually want to spend a month just fooling around with machine learning. I just want to tokenize some text, and it's not in English, so the space tokenizer you gave me kind of doesn't work all that well. So then you can probably just build an estimator, and then you can start to work with the text that you have. But if you've got like a month, and you want to kind of trick your boss into thinking it's a good idea, you're going to want to be building a transformer, and you can build some really cool complex stuff in there. And when we want to build these things, we have to provide a few basic functions, and we'll look at sort of a standard implementation. There's transform schema, which is used to validate that the sort of data that we're training on is reasonable. So if someone tries to ask us to tokenize a bunch of numbers, we'll be like, no. I'm going to throw an exception right now. And then there's copy, which is pretty much useless, but we have to implement it, so we'll look at how to do that. And then we have to provide some parameters for Spark to actually be able to do its really awesome sort of meta algorithms on top of our pipeline. So if we just wrote a traditional Scala sort of model, and we didn't use these special parameters that Spark uses, we couldn't use its really cool, awesome features, and then there would be no point in this exercise. So we're going to make this really high-quality word count stage. You might have thought by coming to a machine learning meetup you were finally going to get away from word count, but I like my big data license, and so I put word count in all of my talks, 100% of the time. I guarantee it, not a guarantee. So this is sort of the most basic Spark pipeline stage. And so what we do is we say, yeah, I just have this hard-coded stage. I need to have a constructor, and I need a UUID, so Spark can keep track of them. And then I have this copy function, and if I needed to do something special when I was copying my stage, I could do that there, but you never do, just call default copy. I don't know why they didn't make it a default implementation. 100% of the time, this is what you want. In my sample set of 2. So then we come to transform schema. And transform schema, everyone's familiar with data frames, yeah? Y'all love data frames? Okay. 2 people gave me sort of this back, so for those of you who don't love data frames, I'm sorry, you have to. So we're just going to say, I'm expecting my input strings to come in happy pandas, and this is sort of, if it's not a string, I'm going to throw a fit right there. Otherwise, my output is going to look like this, so the person downstream can work with it. And then we can do our work. And so in here is where you spend either your months of work or your like 15 minutes of work. Either way, you can write a UDF. You can use the new dataset API, which is much nicer than writing UDFs. But if you want to write a UDF, you clearly can. And this gives us the word count. Yay! And now we want to make this configurable. And now we're probably not actually going to do a parameter search on the input column. That's not going to go real well. Unless we have different features possibly, and we're not sure what we want to work on. But Spark has this wonderful thing called param. And it takes, it's a templated thing, so we can give it all sorts of different types. Pretty frequently strings and doubles are sort of the most common. So we could see something like a smoothing parameter in here, or really any sort of tunable knob your model has. You're going to want to sort of define it this way. And then once you've done this, you can use the parameter grid search that Spark has. And yeah, so the reason why we need to do this is it lets the Spark's meta algorithms work. It does this really awesome. If you're like, Holden, what parameters should my model have? I will say, that's wonderful. You should go look at sharedparams.scala. It's a very exciting read, and I encourage everyone to read it. No, more seriously, you can look at sharedparams.scala to see sort of like how parameters are constructed inside of Spark for machine learning, and you can re-implement it on your own. For unfortunate reasons, all of that is entirely private, so you can't just be like, oh, I have the same parameters as that random forest implementation, I just did mine differently, so I'll just extend that. Sad, very sad. But you can also lie and say that you're inside of org Apache Spark, which is one of my favorite pastimes. So if you're okay with lying about who you are, you can just go ahead and you can start using the parameters that the other models inside of Spark already have. Here, like simple and fun. Okay, so that's exciting. Or not really, we did word count. But we did word count in a machine learning pipeline. But for those of you that want to do actual things, you want to make an estimator, right? You want to do something cool, some real work. Very nice. Ooh, I forgot to put my bear hat. So it's okay. The wonderful thing is you're going to do pretty much exactly the same stuff, except your transform function isn't going to fit on a single slide. It's probably going to be several slides. And what you're going to do is you're going to make your estimator. And your estimator is going to have a fit function. We could look at an estimator, but I've only got 10 minutes. So if you want to look at an estimator, I have my GitHub up shortly, and you can go find it there. And a really good way to sort of figure out what you're doing is to just go and look at the algorithms inside of Spark, as opposed to the ones that I've done. Those ones are probably a bit more professional. They weren't wearing a fuzzy bear hat while they wrote them, to the best of my knowledge. For all I know, fuzzy bear hats are all the rage. So yeah, if you want to look at some really simple estimators, you can go here, and this repo has the code for both transformers and estimators, and you can go ahead and start like making your own, and you can make your own cool machine learning stuff, and you can like publish it on Maven Central, and then I can use it, and then it'll be awesome. Of course, you should buy several copies of the book associated with that repo, and I have no idea why I might say that. The models inside of Spark itself are pretty good, and if you really don't like reading code, the API docs are good, but I strongly encourage you to actually look at the code. The API docs leave a lot out, for better or less, and you can find my slides. Let's look at the GitHub. Oh wait, no, books. I'm going to sell you books first. You should buy several copies of all of these books. It is the gift of the season. Don't buy this one. Even though I wrote it, it's really out of date, and I wish they would stop selling it. But you should buy several copies of all of the other books, only some of which make me money. And this one doesn't, so it's actually a real recommendation. But the other ones, I like coffee. Relatedly, There's a new one which I happen to receive the most money for, which you can buy from O'Reilly, and it is the gift of the season. And it has a chapter on how to do this. And it's a bit longer than a 10-minute talk to see all of the cool things you can do. But there's also some free copies of this book and Learning Spark at the back, which I can give to people if they're interested. And you can give me your email address to spam the hell out of once this book is done, if you are one of those people that doesn't want to give me money for nothing. But I strongly encourage you to give me money for nothing. Cool. And so that's it. Okay, thanks, bye. Yeah.
Thanks for that. So that was it.